The brain sends a signal to the axon terminal of the motor neuron. The signal goes through the synapse to the sarcolemma. Sarcolemma, the membrane that surrounds muscle tissue, receives the signal which triggers an action potential.
The action potential travels along the sarcolemma into the T tubules. Then it hits the receptor, which signals the calcium to be released by the sarcoplasmic reticulum.
We focused in on half a sarcomere. The sarcomere is inside a myofibril, which is inside a muscle fiber. The sarcomere helps to contract the muscles. This is the actin. The little bead is the troponin, and this is where the calcium attaches. The blue part is the tropomyosin, which is currently blocking the myosin head binding sites.
This is our myosin. These are all the myosin heads. All around the myosin there is ADP and P left over from the previous ATP, which helped break the previous crossbridge that was made.
The calcium bonds to the troponin. Then the tropomyosin moves so that the binding sites have been revealed. Then some ATP comes in and the ADP and P float off.
The ATP helps put the myosin heads into a high energy configuration so they will attach to the binding sites, making a crossbridge. The myosin heads go into low energy configuration, causing the myosin heads to pull the actin towards the center of the sarcomere or H zone. This is called a power stroke.
During rigor mortis after death, there is an excess of calcium building up in the body and not enough ATP to break the cross bridges that have been made, resulting in the contraction of all the muscles in the body so they stay rigid. Normally the ATP comes in and breaks the cross bridge, but in rigor mortis it doesn't.
When rigor mortis isn't happening, ATP comes in to the myosin heads bound to the actin and breaks the cross bridge. This causes the myosin heads to detach. Then the ATP breaks into ADP and P, and the actin moves to its original position.
All of these things happen very quickly, and lots of different myosin heads can be moving at different times. This is how our muscles contract.